Hey guys, this video goes along with section 9.5, which is about trig ratios. We use trig ratios to figure out missing side lengths of a right triangle if we're only given one. We could also use trig ratios to help us figure out angles of a right triangle, and that will come later on in one of the next videos. Okay, so the first thing we need to do is make sure we understand how to describe segments relative to a given angle. So that means basically we're using angle A to describe the other sides, okay? Well, this segment here, AC, that's across from 90 degrees, so this is a special side that we always know is our hypotenuse, okay? So relative to angle A, we already know that AC is the hypotenuse. The other two sides, in the past we have just called them the legs, but there are some additional words that we could use to kind of distinguish them from one another, okay? Now segment AB, that's the leg that is right next to angle A, and we use the word adjacent to describe something that's right next to another geometric object. So adjacent leg would be AB, and then BC is opposite of angle A, so this would be your opposite leg. Okay, when you're marking up your diagrams, it's really important that you kind of put these letters or some little clue to yourself so that you can keep track of what information you are given. Okay, so if you went through that discovery activity that we did in class, at the end there it had you record all the special ratios that were given. And we came to the conclusion that when you find the ratio of an opposite leg over the hypotenuse, that special ratio is called sine of an angle. And it's spelled this way, but it will be abbreviated on your calculator like this. Okay? And then your adjacent leg divided by hypotenuse is what we call cosine. Again, it's spelled like this. This is how you say it, but it's abbreviated on your calculator as COS. And then lastly, the opposite leg divided by the adjacent leg is another special ratio that we found out, and we call that one tangent, or TAN on your calculator. Okay, and then we kind of came up with this little shortcut to help us remember sine, cosine, and tangent, SOH CAH TOA. I would definitely recommend you write that down on every homework, every practice worksheet, and every quiz or test that we take involving this topic so that you remember it. Okay, so let's do a couple examples. Still working off the same triangle from above. The question is find sine of angle A. So relative to angle A, I need the opposite leg and the hypotenuse. So opposite of angle A is 4, and my hypotenuse is 5. So sine would be the opposite leg divided by the hypotenuse, 4/5. You could also write it as a decimal, 0.8 if you want. Cosine of A means we need the adjacent leg, which is 3, and my hypotenuse, which is 5, 3/5 or 0.6. And then lastly, tangent, which is the opposite leg divided by the adjacent leg. So in this case, 4 divided by 3, you could just leave it like that. Okay, remember that all of these are relative to A. If I asked you to find relative to C, or sine of C, then you would have to relabel your sides. Okay? Here's another example, so go ahead and pause the video, copy this down in your notebook, and then resume the video to check and make sure that you have this concept down. Okay, so take a look at the answers that we got here and then compare. The answers that we got to our previous example were the same. Can you think of any reason why that would happen? Well, actually, if we compare the side lengths, remember the first triangle that we had was a 3, 4, 5. And if we compare the side lengths on this triangle, 6, 8, 10, we can see that they're just doubled. So really what we have are two similar triangles. And whenever you have similar triangles, you know that the corresponding angles are going to be congruent. So for example here, angle A on both of these triangles would be congruent because these are similar. So that is the reason why these actually came out to be the same, is because the angle measures are the same. And that's the whole reason why we have these special trig ratios. Sometimes when you're using trig ratios, the angle measures will already be given to you. Okay, so for example, if I gave you a right triangle with a 48-degree angle and I said find sine of that angle, but you don't know any of the side lengths, you can type this on your calculator very easily. Okay, the most important thing is to make sure that your calculator is on degree mode. And what I mean by that is to take a look at your screen and make sure that it says degrees. In this case, you can see that it says RAD, which is not degrees. So I need to push this button, DRG, push that button, and then scroll over until you're on the right mode. Okay? And then it should say DEG at the bottom. If you're not sure which mode your calculator is in, then just bring it over to me and I will fix that for you. Okay, and then from here it's pretty straightforward. The way that you're going to type these on your calculator is by locating your sine, cosine, and tangent buttons, and then just type it. Sine 48 equals 0.74. Do 0.743. And then you just continue doing that. So clear. The next one is cosine of 72. So 0.309. And then works the same way for tangent, 53. Got 1.327. Okay, so that's how you would use your calculator to type the trig ratios right on there. Here are a few examples that you can kind of try, kind of as an exit slip to this video. See if you really understand what's going on here, and then after you're done, resume the video and you can check your answers. I hope this video helped you guys out. If you've got any questions, please make sure you come see me to schedule an appointment, and good luck to you.